All right. Let's begin now. Exercise. This is exercise 2B. I just thought I'd make sure I go through elimination method and a literal equation. And I want to go through exercise 2C as well, just to do a distance midpoint formula to make sure that I'm not assuming that you all know it, that you've got some notes on it and how to do the questions. Now, just to, before we move in, was it yesterday or the day before, Trent's question about the continuous point and an endpoint. And I did my research on that, and there are a lot of experts out there who aren't even sure themselves. The definition seems to change around, but I've got more of a, I think it was about 60% on this particular answer and 40% on the other. But this is my answer for it based on what I've read and a definition. I saved that PDF as well, and I'll put it up onto Schoology, and I think this is your definition of continuous function. It has to satisfy three things, which we already know. It has to be one, for it to be continuous, it has to be defined at a point, right? Number two, actually I'll write this down as well. So it needs to be defined at a point. So f of x is defined at x equals a. That's the first step. So that means if you sub in x equals a, there is a y value, hence why it's defined. Number two, just because it's defined doesn't mean it's continuous, especially in the piecewise function or hybrid function. You can have them separated, but the points exist. So the next part that you need to prove as well is that the limit exists. Now, in this particular definition, they broke it up into an extra two parts. Okay, so they say the limit as x approaches a from the left of the function is equivalent to the defined value, so from step one, and also step three, limit of x approach a from the positive side is also equal to part one. Okay, so part one says, does it have a y value? We say yes. Then part two says, all right, well, if I approach from the left-hand side, does it still also approach this y value? If it's ticked off, we're like, great. And then what about if I approach it from the right-hand side? If I approach from the right-hand side, does it also tend towards the same y value? If all three boxes are ticked, we say it is continuous, right? So by this definition, then, the question is, what happens when you have an endpoint? So let's say something like that. Actually, okay, I'll do it that way. If we do it like this, then technically we know that every single point is defined at this moment. Every single point we can say it approaches something. The only question that we have are the endpoints. Now in this particular case here, the example we did in the test yesterday, they were both open circles. So it made sense that this doesn't satisfy the first condition. First condition means that x equals whatever this open circle is, it's not defined. There is no y value there. But the question is, what if it was closed circle for both ends? Is it continuous or is it not?
Isn't it like that if you've written a domain that is between those points and told to not include that one, you're not including the point directly before that. You're not saying that point is on the graph, but don't include it. You're saying that point is not on the graph, but you write that so you know that it's not included. So like with like a log graph, you know that x is, when x is negative, you know it's not there because you define domain. That doesn't make sense.
But it's continuous amongst all those points in between.
Yeah, but that's the same difference. Because you're not including that last point.
Yeah.
That is just like a...
So if I said this was B and I said this was A,
Yeah.
then I would say this function here is continuous between A towards B.
Yeah, can you also say, like, square bracket A, B minus H, square bracket?
No, we wouldn't do that, but I guess you could, but then you have to define...
Wouldn't that make...
Which one? This one?
Yeah, because it actually explains something.
I don't know. It's continuous all the way up until except this point, which is what you're saying. It's up until just before B that is all continuous.
Yeah.
So by not including B, then that's what you're saying. B minus H is not including B.
Yeah. But doesn't that make it still...
Yeah. Yeah, but just not B.
Yeah, but B is like...
Yeah. So, yeah.
So,
not on the graph, so why are we listing?
Yeah.
Oh, I see what you're trying to say. I think it was sort of assumed it was. Yeah, it isn't. But I think, I see what you're trying to say now. Yes, so I didn't see what you're trying to interpret the question as. All right. Oh, okay.
So like, the answer is just like 2 and 4 and 0, and one people just take 0.
I see what you mean. Because it's not included, then we don't say that it's, it's because, I see what you're trying to say. In the questioning, when you do it in the BCE, at the end of the year when they say, where is it not continuous? Because if you have a piecewise function, if I included this point here, if I had a coordinate here and moved on, I understand the domain clearly says A to B, but B is defined here, but it's not there. Then therefore you say this point here is not continuous. But if you don't have a point, then do you call this this point here, do you even include it at all? Yes, you're right. You say that it's not continuous, right? And it makes sense. You would say that this point is not continuous because it's not defined. Like that particular point at B, is it continuous or is it not, right? In the question, when they ask you, list where it's not continuous, which points are not continuous, because you put in the domain A to B, there has to be something said about B. Okay, so I know B is not there, B doesn't exist, but you define it by saying B doesn't exist. I know it says in the domain, but in our question, we didn't have a domain, we had pictures. So you would say, at these endpoints, that open circles, they don't have, even though it's obvious that B is not there from the graph, we're just saying that's not there. We're saying it's not continuous at those points. Yeah, so that's generally what they're trying to ask, but I never thought of it that way. I get what you mean, because it's not there, so why would you even bother saying it's not there? You might as well say for all these values here. You know, you might as well just say, well, this is not there too, hence this is not continuous too. I think it's just because we put a restraint, we said A to B, so we're going to say something about A and B between those points. But now going back to that question that you asked yesterday, you said if it's closed circle hypothetically, say both of these were closed circles, do you consider them continuous or discontinuous? Because based on the three conditions we have, some answers say no. The majority, when I say majority, I'm talking about 60% versus 40%. Majority says that it is. Okay, so if you follow this definition, if they're both closed circles, yes, condition 1 is ticked off. So yes, they are both defined because they have a y value. But when you go from, let's say, the left endpoint here, it says if you do limit approaching the value from the left for the function, well, technically you have nothing on the left. So therefore, it's approaching undefined, or you can't answer it because we don't know what the left side is. Whereas on the right-hand side, you would then say, yes, coming from the right-hand side, it tends towards this y value. And whatever this y value is it's equal to the same as f of a. That's why we'd say, yes, it ticks off the third point, but it doesn't tick off number 2. But then if you look at this endpoint, if it was closed circle, B, then coming from the left-hand side, then it is defined, but coming from the right-hand side, it's undefined. So at all times, the endpoints, you are only satisfying 2 out of the 3, and that's why they say those endpoints are not continuous. However, reading the,
Yeah, just on the point you were saying you're coming in from the right-hand side towards B if it wasn't close. Why is that undefined? Can't you still approach it again?
Yeah, but you don't know what's on the right-hand side, because the function could be come down, it could be stopped here, we don't know, there's nothing to go with saying from the right-hand side. There's nothing to start from the right. There's nothing, no line, nothing, no information is given, so we can't say, yes, it's tending towards whatever that y value is. We can't say that, because we don't know. And because of that, they say that these are undefined. However, in your textbook, or not in your textbook, in this particular definition I found, this is what they say. I think I still kept it. Here we go. So those are the 3 conditions you have. But on the bottom there, you can say a function is continuous providing you say from which limit. Okay? This is where there's a fight on the forum where they're like, no, you're wrong. And the other person's like, no, you're wrong. Based on the definition. It's really interesting to read. I was sitting there and some of them read some proofs that I've never heard of. I'm just like, all right, I just want to know, is it continuous or is it not? But I found this document, and I'm just going to stick with this document. I think this is what you're meant to know. And I don't think that question comes up in the exam, so it's just good to know, but probably won't have to have that problem to deal. But this one says here that you can say a function coming from the left or right, you can say something is continuous from the right. So when you say a function is continuous, that's with the exception of left or right, doesn't matter. But when you wanted to find the endpoints, you would have to say A, so the example I had just now, you would say A, the coordinates A is defined or is continuous from the right. And then you would say at B, it is continuous from the left. Whereas if I was just talking about anywhere in between A to B, I'd say it's continuous between A to B. That's just a language that they say. But what my point is yes, you can say A is continuous from the right.
Yeah. Like, okay, just so on SAT, yeah, they asked us where this is not continuous. Like, what is A? Is that continuous? Is A continuous?
Yeah, but then this is how you say it. But this is what I'm saying. In your textbook, it won't say this, but it might be good just to write if it's in the exam. Say it's continuous. A is continuous from the right.
But B is also continuous.
B, if that's close circle.
So, but it's open stuff.
No, because it's not defined there. Because it doesn't satisfy the first condition. Yeah, but if it is closed circle, then you can say at B it is continuous from the left. So you have to use the word from the left. You can't just say it's continuous. Because it's not continuous, it's undefined on the right-hand side. So you have to say it's continuous from the left. That's the language that they encourage to use from this document. From your textbooks, I'm not seeing any questions that are proposing that idea. I think most of the time it's pretty obvious. Just label where is it continuous or not, and you say particular points. That's it.
So what would you call point B? So if it was like a multiple choice, you get a short answer. So would you just say it's not continuous at point B, or
yeah. At point, yeah, at x equals b, it is not continuous. Yeah, or at point b, it is not continuous. Usually, if they ever give you that kind of question, they don't give you the graph that I just gave. They normally give you something like this and carry on. And they say, list where it is not continuous. And you would say, at x equals b, it is not continuous. And then if they ask you to show it, then you've got to go through those 3 definitions or 3 checklists to prove it. Yeah? All right, so that's just clarifying that. I did the research and I thought I'd make sure I let you guys know. Now, let's do exercise 2B, 2C. It's really just your algebra. Really, rest of this you learned coordinate geometry, distance, and midpoints. You probably did in special already. That's for 2C. But I just thought I'd go through it just to make sure you know. So let's do this one. Question 2A. So we're now not solving just linear, just a simple single linear equation. We are now doing simultaneous of literal equations. And in this case here, you've got ax plus y equals c and x plus by equals d. Your goal is to solve for x and y. So using what you learned from year 9 and what you remember from simultaneous equations, what do you need first? What's the first thing you need in order to do simultaneous equation of some sort? So let's say elimination method. How do we do that? What's the first thing, Anna?
well, depending on how many unknown variables you have to do that many equations. So
Yeah. In our case, we only want to find x and y. So in our case, we got 2 equations, 2 unknowns. Now I want to solve for x and y using elimination method. How do I do this? Mazen.
Times the second equation by a.
Yeah. So in this case here, there's a lot of ways to do this, but you need to make one of the variables have an equal quantity. In our case, Mazen wanted to make x variables equal quantity. So how did he do that? He said, I'm going to multiply, I'm going to show it here, I'm going to multiply x by a, but that means I'm going to multiply everything else by a as well. What that does is, it now gives you, wait, did I do a, b, x? No, I did the other way, okay. If you do it that way, what you will get now is you have ax plus y equals c, ax plus aby equals ad. Okay, why you want to do that is because now that you have the same quantity, you can use elimination method, add or subtract both equations to get rid of them. So with ax and ax, the only way to remove ax from each other is if you add or minus. Minus.
Or divide.
That will cause a lot of issues, actually. So you do ax, take away ax, that becomes 0. Then you got y minus aby equals to c minus ad. I still want to find out y. How do I do this? What's the next step? Yes, Ben.
Take out a factor of y.
Take out a factor of y. So you can see here, take out a factor of y. Then how do I find y now? What's the next step? What do I have to do? I got y times 1 minus ab. I need to get y by itself. Yes, Will? Fantastic. So y equals to c minus ad divided by 1 minus ab, because that's multiplication there. So inverse of that is divide both sides. And what you've just done is you figured out how to solve for y using elimination method. Once you got y, you can do the same thing for x, and that's how you find x and y. Yeah? So what you can see is this is how you normally would have done it if they were numbers, but if they're not, this is the approach. You just have all the letters there. Yeah? That's what exercise 2B is about. It's getting you to work with literal equations, and the reason why you need it is for exercise 2E. When I start talking about determinants and telling you why you have infinite or unique or no solutions, that's the only way to understand it. You can start rearranging, you understand where the formula comes from. Yeah? That's the only reason why they get you to do this. That's why I'm saying, technically, you can ignore 2A, 2B, 2C, you can ignore 2D, and you only start on 2E. That's literally the only one exercise you need to learn is 2E and then 2F. That's it. So if I really wanted to teach you and just make it quick and easy, we just go on to 2E without going over the basics. So the basics just like, is your algebra right? Can you sort of manipulate things? Do you know what the distance formula is? Do you know what the midpoints are? If you know what those are, you don't have to do 2B and C. The only focus you need is 2E. Okay? 2E is your revision of matrices and talking about what matrices are, what a determinant is, what an inverse matrix is. That's what 2E is about. Yeah, that's where everything comes from.
Is there a sheet that gives us like recommended questions?
Yep, it should be on Schoology already for chapter 2. Yeah, it should be there. Okay, so that's thank you. That's exercise 2B. 2C. I'm just going to move on to 2C. 2C is the formulas. These are your formulas that you need to know. So you already learned it in year 11 or specialist distance formula. It's Pythagoras' theorem. You've got your midpoint formula, finding the average of your x values and average of your y values. And then you've got your gradient, y2 minus y1, x2 minus x1. So we should know this from chapter 9. And then last one from chapter 9, remember tan of an angle is also the gradient. That's what you're doing in 2C. So you can see 2C is just really revising everything that you've learned so far to the coordinate geometry, because you're going to need straight line equations to understand matrices. Okay, and I taught it last year as well. I'm pretty sure it's an easy concept to understand. I did. I even taught it to my year 11s this year, and they picked it up. So it's not a hard concept. You just got to understand what you're really doing. Once you understand it, it's easy to do. Yeah, so chapter 2, you can knock it out very quickly, and we'll catch up with everyone else very soon. But you got to get your basics, okay? So that's 2C. We're going to do a quick example. Let's do question 1 of exercise 2C. Let's have a look at this one. Let's go. You got a straight line. Right down. You got a straight line that passes through the points -2, 6, 4, -7. Find the distance A to B. You can draw this if you want, or you don't have to. You've got the formulas on the side there. So how do I find A? What do I do? Distance from A to B. What do I do, Aaron? Fantastic. These are your coordinates, A to B. So you can draw it if you want, just to visualize it. -2, 6. Here, and then you got 4, -7, so 4, -7, let's say down here. You got those points A to B. Your job is to find out the distance. You can work out the height, the overall height by the overall distance, and then you can find out the hypotenuse. That's what the distance formula is. It's just the Pythagoras' theorem. A squared plus B squared equals to C squared. That's what this is. Okay, so you're just finding out the height, and what you're doing is y2 minus y1. So we can call this y2, call this y1, and we put that all in. You get now y2, -7, take away 6, so -7 take away 6. That tells you the height. And then 4 take away -2, tells you the length. A squared plus B squared equals to the hypotenuse squared. That's where the AB squared is, and so if you square root both sides, you find out AB. So that's where the distance formula is coming from. It's just Pythagoras' theorem. Okay? So that's part A. Sub it in, solve. Let's do part B. How do you find the midpoint of a line segment AB? Midpoint is basically on, you want to find the middle of your two x values. Now, if I told you 5 and 7, how do you find the middle? Now, we all know 5, 7, and the middle has to be 6. But literally, well, how did you know it's 6 besides the fact that you can picture it in your head? Another way is finding the average, because 5 plus 7 gives you 12. Half that. Because there's two numbers, sum of normal numbers divided by number of numbers. So 5 plus 7 is 12. 12 divided by 2, 6. That's another way of finding it. So if I give you negative 3 and 10 now, you have a way to figure it out. So negative 3 and 10, the midpoint has to be the average of those two. So negative 3 plus 10 is 7. 7 divided by 2, you know the middle is 3.5. Okay, so from negative 3 to 10, the middle has to be 3.5. That's a quicker way than trying to picture it and trying to make it even. Yeah, the average allows you to find out what the center, what the middle should be. Yeah. Okay, so that's where the midpoint formula comes in, and you're literally just finding average for the x values, and you say, all right, well, it'll be 4. The x values are 4 and negative 6, so you say 4 plus negative 2 divided by 2, and then negative 7 plus 6 divided by 2. That tells you the average for y's and the average for x. That gives you the middle, hence the midpoint. Okay? Then we move on to C. Find the gradient of a line AB. Again, that's back to year 9 maths, y2 minus y1 over x2 minus x1. Yeah? Now, let's try this question. Let's say, find the equation of the line passing through the point negative 1, 3. Now, this is a linear equation. It's back to year 9, year 10, year 11 mathematics. Let's try to do this. When we know it's parallel, what does the parallel tell us? Why do we want to know it's parallel? Same gradient. Now, if you look at this equation here, what is my gradient for 2x plus 5y minus 10 equals 0? What's the gradient? How do we know that? You rearrange the equation to make y the subject. So here we go. We've got 2x plus 5y equals to 10. Add 10 on both sides. Minus 2x on both sides. I get 5y equals minus 2x plus 10. And then divide 5 on both sides. You get negative 2 on 5x. And plus 2. So here we can tell that the gradient is negative 2 and 5. So that means if it's parallel, the gradient for this new line has to also be negative 2 and 5. Yeah, so if I write out my new line, this is my new line. There's a line called y equals mx plus c, which I don't know, but I just knew because it's parallel, m has to be negative 2 and 5. Problem is, I still don't know what c is. Yep, because we're trying to find the equation of the line. So the equation of the line needs to have a c value. So how do I find c now? What do I do? Yes, Anna? Fantastic. You got the point when x is negative 1, y is 3. You can use that point now. You can say, well, if x was negative 1, then apparently y should be 3. And you can solve for c from there. Okay, what I'm just doing with you now is actually chapter 10. So the skill to be able to work with linear, meaning parallel, and then perpendicular. That's what you're doing for chapter 10. Finding the tangent line, find the perpendicular line, find the parallel line. All of those skills that you're doing now, 2B, 2C, is just to make sure you're ready for chapter 10. Okay? So that's why I'm saying, if you already know this and you feel that you're confident with it, you don't need to do 2B, 2C. You can jump right to 2E. That's when I'll teach that tomorrow. Make sure that we're ready for what chapter 2 is all about. Okay, but 2B and 2C is kind of like, to me, it's a waste of time. Because if you already know it, you understand all this, there's no point doing it laboriously. Yeah? Work on things you don't know, don't do things you already know. Yeah? Yeah, I'll conclude it with that. Just conclude it there. That's 2B, 2C, just a general idea of what you needed in chapter 2. But the main focus is 2E. I'll do that tomorrow. We'll revise what 2E is all about. Matrices. If you can go back to your special book, have a look at how to add matrices, multiply matrices, and then inverse of matrices. That's the key. Okay, that's what I want to talk about, inverse of matrices. But I can't do that unless you can add, subtract, multiply with matrices. Then it makes sense of what I'm talking about. Once you get that, then you understand what you're doing when you find the determinant. You understand why it has infinite, many solutions, no solutions, and unique. Then it all makes sense. Yeah? But that's all you can revise on from Spesh. Smash. Otherwise, that's it. We'll conclude it there. And that's it for today. Yep, I'll come right over.